24 consecutive live webcasts delivered by up-and-coming speakers and experts from the PASS community. All sessions will be available next week on 24hoursofpass.com. My name is Aaron Nelson. Since this edition is focused on growing our community, I wanted to take a moment to thank Dave Dustin, Rob Farley, and Pam Shaw for helping me start my speaking career back in 2010. I have a few quick introduction slides before I hand the reins over to Konstantin. He will speak for 40 to 45 minutes, and then we'll move to the Q&A, where you can ask any questions you may have. If you're having any issues, just type your questions into the questions pane on GoToWebinar control panel, and someone will assist you. To maximize screen, use the Zoom button located in the top of the presentation window. Feel free to enter your questions into the Q&A field at any time. The questions pane is located on the right side of your screen. Once we get to the Q&A portion of the session, I'll read off your questions to the speaker. Since all attendees are muted, you'll need to submit questions by typing in the Q&A field. Note that there will be a short evaluation at the end of the session. Your feedback is important to us, so please take a moment to complete it. It will show up on your screen. I'd like to take a moment to thank our presenting sponsors, Microsoft, Cisco, and Dell Software. In addition, I'd like to thank the support sponsors for this event, SQL Sentry, HP, and SolarWinds. This staging of the 24 hours of PASS would not be possible without their support and dedication. And they are the reason this event is available free of charge. Next, I'd like to bring your attention to the upcoming PASS Summit, taking place in Seattle, Washington from October 27th through October 30th. PASS Summit 2015 will feature over 200 sessions with world-class SQL Server experts. Planned and presented by the SQL Server community for the SQL Server community, PASS Summit is single-handedly the largest gathering of SQL Server and BI professionals. With over 5,000 attendees from all over the world, PASS Summit is also a great place to network and meet face-to-face with experts, peers, and Microsoft MVPs like myself. More importantly, PASS Summit delivers on providing you with the answers to your SQL Server issues, along with the knowledge, strategies, and skills you need to stay ahead of the curve. Contact your local chapter for a discount code to save $150 off your registration. Optimize your savings by registering before the end of Sunday, July 12th. Right. And now, please allow me to present the speaker of the hour, Konstantin Melamud. Konstantin is located in Pittsburgh, Pennsylvania. He has experience working with over 400 customers and helps customers find solutions with their SQL Server environment. He works at RDX, Remote DBA Experts. Konstantin, take it away.
All right. Well, thank you everyone for attending. This is Optimizing Your Data Warehouse for OLAP Processing. And look, I just want to begin by stating what you kind of should already have familiarity with. Well, you obviously should have a cube. And the other thing that we're probably not going to go over too much is, look, you have to have a working knowledge of TSQL and actually OLAP. Because we're not going to show you how to build a cube, we're just going to try to see how to build a cube faster. So what is really the main problem with our processing of the cube? Well, as our data set grows, generally the time to process the data warehouse increases, and we run past our maintenance window. Not like the maintenance window that we have is generally at night or on the weekend, and a lot of times that window is limited to like 4 to 6 hours because there's an ETL process that needs to run and all other things. And as your data set grows, that time just increases exponentially, and you run out your window. And you already beefed up your server. there's really not much you can add from the hardware resources perspective. It is what it is. You just have to do something to actually fit within your window to get your data to process within the time that's allowed. And the other thing, obviously, is the changes that you make, they have to minimally impact other processes running against the data warehouse, ETL and so on. So you might actually speed up the cube processing by maybe putting some indexes on, but it'll actually slow down your ETL, so you end up in the same boat where you're running past your window. And of course, if you're a developer and working with a business intelligence group and you're running past your window, your production DBAs probably will not like you very much if they keep getting calls saying, hey, your process is still running, like the server is slow, like what's going on. So, and if you are a production DBA, I'm sure you don't want to get alerted saying that by the customers saying that the same thing basically, and then you call in the business developer and like, what are you guys doing? So what are we actually going to cover today? So what is our really goal? We want to try to minimize our downtime window, and that's time required for processing. So a lot of times it's combined with the ETL process and a whole bunch of other things. So, but we're only going to concentrate on the OLAP part. We're going to talk about some best practices considerations for OLAP, and we're going to concentrate on some of the enterprise features to increase your performance for OLAP processing. If you have a very, very large data warehouse, I'm hoping that you guys are already running enterprise edition of SQL Server just because of the feature sets and the memory requirements and all that stuff, so you actually be able to take advantage of that. And we're going to briefly talk about actually incremental processing, which actually can also help you speed up your window. So some of the best practices we're going to talk about, or at least mention, is use of surrogate keys within your cube structure. It's actually very important because your computers really just like to play with numbers. I mean, that's what they're best at. So if you actually use surrogate keys, it will actually help you, your optimizer engine and a data warehouse to actually pull the data in the most efficient way. And it just works a lot better if you actually do that. Parallel thread adjustments. OLAP has an ability to actually pull data in parallel modes, and sometimes if you have a really beefy hardware, you might actually want to increase that thread count so you actually can pull a lot more data at the same time, and that way actually it will also increase the amount of data that's being pulled and then decreasing the amount of time that it actually takes to load all the data into your cubes. The other thing we're going to talk about, and actually that we'll actually cover a little bit, is avoiding implicit conversions. That's actually could really hamstring your processing if the way your queries are defined or the fact tables or the processes within your cube are defined have to use the implicit conversion on the data warehouse side. That will actually impact you from the CPU and sometimes even worse because you actually end up with a non-sargable queries and then you end up processing a lot more data than you actually need. The other key thing is actually physical and logical model alignment. Generally, that's kind of almost assumed, but a lot of times you actually, whenever you come into an environment, you already have an environment there, so it's not something that you developed. It's something that you kind of inherited. And when you start looking at it, whoever developed it before, they might have had a much smaller data set, and their physical model was actually different from their logical cube model. And as their data set grew, the performance just went really, really, really south. And I'm actually going to show you an example of that from an existing customer of ours that actually ran into the same issue, where they, during the inception of their data warehouse, their data sets were pretty small, and they could get away with processing and building their cubes with the time allowed and have misaligned models. But as their data set grew and then they got more customer onboarded within their environment, they just ran out of their windows. The other thing I wanted to mention is within the SQL Server 2014 Enterprise, there's something that's called Hackathon in-memory object options, which is something also you might want to consider using for some of your dimensions, especially the static ones, just because the bulk of your data will probably come from your fact tables. So that's the data that's actually going to be most likely cached in your buffer pool in the SQL Server. And if you're using a hackathon in-memory objects, then you guarantee that some of your dimensions will always be in memory and they won't be pushed out by the processing of the fact tables. And the last thing I wanted to mention is actually to minimize extensive calculation as part of the cube build and processing. Generally, that you can do it either as part of the SSAS, but if you go to SSAS performance tuning session, I'm sure they'll tell you to do it as part of the database engine. So, I mean, it's probably kind of flows downhill. Look, the database engine will probably be the best place where you can actually do the calculations to bring into your cube structure. Today, we said we're probably going to mostly concentrate on implicit conversions, physical and logical meta alignments, and some of the other enterprise level features that we can actually use to help us process the cube faster. So I'm going to show you really quick. This is actually an example of an existing customer cube structure as a segment of it. So this is what it looks like within actually the Visual Studio Bids Manager. This is part of their cube logical model, which doesn't look really that bad until you actually look at the DSV that all those facts and dimensions are coming from. And that looks like that. So there's a lot more tables that are actually comprise the fact table or the dimension tables. And I also have an example of the fact table definition, and that looks something like that. So this is one of their fact tables that actually is being processed as the cube is built. And as you can see, there's a lot of functionality here that it will, if the data set it gets really, really large, will really slow down your processing. We're using some window functions for row numbering. We're doing derived tables, subselects, aggregations as part of the fact table definition. I mean, this is a pretty massive query, and I imagine actually processing that through like 100 or 100 million records. I mean, that's just going to take forever. So I just wanted to show you that part. Okay. All right, so what enterprise features we actually can use to help us increase our performance of our cubes? One of them is definitely compression. So with enterprise data warehousing, compression is available in 2 different modes, and it's almost a no-brainer to use because it's definitely going to give you a performance increase. And still the slowest part of our system as far as from a database engine side is our disk subsystem. So if you minimize the amount of data being pulled off the disk, it'll increase the performance of your processing because it's just that's the slowest part of our system. The other thing we can talk about is actually partitioning, and that can actually exist on 2 different models. So you can actually do a logical model partitioning, and that was basically within your cube structure. And you can actually do partition alignment to physical data warehouse. So where your cube is partitioned exactly the same way as your database on it, or data warehouse database on a database engine, which actually will help you use features like a partition elimination, and that actually limits the use of your additional indexing that's required to actually provide help for speed improvements. The other thing I'm going to mention is actually process add functionality. And that's something that you can actually use to also do kind of incremental type of processing to just adjust for the data that's actually delivered in a period of time, like 24 hours or whatever your time increments are. All right, so let's talk a little bit about compression. So there's 2 types of compression settings that we can actually use. There's a page compression, and then there's a row compression settings. So generally speaking, for your fact tables and dim tables, you can actually use either or, and that kind of depends on how they're being loaded. So for the fact tables, most likely you will be using, or you should be using, a page level compression, because generally those are loaded as part of like a big bulk insert process. It will cost you a little more on the CPU, but it's like the savings overall is going to be more effective than row level compression. With a dim table compression, you can actually go either way, depending on how DIMs are actually being populated. If they're actually pretty active changes on the DIMs, like slowly changing dimensions, you might want to consider row. But generally, it's in the page level compression also works if they're more static. And just by compressing your table, you actually guarantee to increase your performance by at least probably 70%, if not more. All right, so I'm going to show you some of the compression settings demo, and where is it? Nope, wrong one. All right, so here we're going to be using AdventureWorks Data Warehouse 2012 database for our demo purposes. I'm using 2014 SQL Server, however, but it's the database itself is actually AdventureWorks 2012. So this is the query that I'm using here is one of the fact table partition definitions that's within the AdventureWorks Data Warehouse Enterprise model. So if you actually run that query and I get my execution plan and I get my statistics IO. So in order to process that query, I had to actually read 2,062 pages from disk. Now I have SSDs on mine, so it's actually pretty quick, but if you have a smaller or slower disk subsystem, that actually might actually take a little longer. So how do you actually do the data compression? You basically just have to rebuild your clustered index. In this particular case, I actually have to switch to a different demo because this is a different index key. So the other thing I wanted to show you, it's exactly that I'm running here. And this is also playing into the logical and physical data misalignment. So it's the same key. And as you can see that I'm only reading a subset of data because this is a partition within a data warehouse, but it's actually scanning the entire table to give me that subset of data. And I have a missing index recommendation, which is actually something that saying, okay, if you create this index, it will make it better. Now, of course, we both know that we should never believe implicitly what SQL Server tells us because sometimes it recommends bad things. So in this particular case, it recommends this index. And if you look at the actual index, it's basically another clustered index. It's giving you the key that it wants to be indexes or a date key, and it wants to include every column in the table. So it's another covering index, basically another copy of a clustered index that you're creating. And if you create that, it'll work actually pretty well. And then you run the query, it will work just fine. You'll see that your I/O wouldn't drop down from 2,000 to 547 pages, and the execution plan looks great. But again, you're creating another duplicate index, which is actually not very good. So in order to actually fix that, you actually just need to change your actually clustered index to be the order date key, because that's what your queries from the cube actually want to see. And in order to do that, I have to drop the existing table that we're looking for here is, obviously we're working with fact internet sales measure group, and the clustered index here is on primary key, which is sales order number, sales order line number. So now to drop it, I actually have to drop some constraints, which I will do right now. I already dropped it, okay. And if I do the same query again, I actually will see that it does the clustered index seek. There's no, does a little more I/O just because it's a clustered index and it has to be ordered and sorted than a non-clustered index, but the difference is minimal. It's definitely much better than doing the entire table. And again, with your larger tables in your data warehouse, that numbers could be drastically larger. I mean, you could be talking about millions and millions of pages. Now, the other thing that's great about AdventureWorks, and I got to give props to Microsoft for that, they have a wonderful combination of some good and bad practices. If you actually look at this, this is an implicit conversion. So the order date key itself in the columns is an integer, but they're passing in a string. And of course, the SQL Server likes to play numbers, so it will convert the string to an integer. And in the newer version of SQL Server, actually almost do it implicitly, and sometimes they don't show it. Like in this particular case, it didn't show it, but you can see it actually converted it to an int. If you look at the seek predicate itself as in a tooltip, it shows up as an integer as opposed to the actual string, but their conversion is still happening in the background. The other example of a really bad implicit conversion is actually a non-sargable operations, and I'm going to show it to you. Hopefully you guys don't have that within your environments. So I'm going to drop that again. And I'm going to change my column to a varchar. And recreate my clustered index. And now I'm going to run exactly the same query, but this time I'm saying, okay, I actually want to pass in an integer. So it's exactly the same query, I just changed where the conversion is happening. So I converted my order date key to a varchar, and I actually am passing in strings. And what you get is actually a clustered index scan. I said, starting with 2012, the optimizer got a lot better and actually detects bad conversions or some of the implicit conversions. So you'll notice if you actually run this query, you'll get this wonderful exclamation point on your select statement. That generally means something is wrong. What it's telling you is that this query is non-sargable. It's actually converting the order date key to an integer, because it likes to play with integers. And if it's converting the column that it's trying to seek on, it basically becomes a non-sargable query, which is it can't search for an argument that it's actually trying to return data for, which is a really bad thing. If you run into those kind of situations, you're going to be doing some schema changes on your data warehouse to fix that. Okay, let me actually drop all of that back. Okay, so actually let's go back to the compression demo. So I already did this, so I actually have the right cluster key right now, and in order just to compress it, all you have to do is within the with options, you just have to specify a feature for the compression. Obviously it's an enterprise level feature, so if it's on standard, it won't work or it'll give you an error. And the only thing you have to do is says data compression equals page, and all the other settings you can sort and modify however you want. So if you remember, this query took about 2,000 pages to return, or 679 pages to return. Now that's actually a proper clustered index. And if I compress it and run this again, I basically cut my I/O by 4 times just by compressing the clustered index. And it's still a seek, so everything looks good. It's just a CPU overhead, and the CPU overhead will only come into play actually most of the time during the load process. During retrieval, it's actually very minimal. Now I can actually do the same thing with row, and I'm doing that just to demonstrate that it's slightly less of a compression gain by doing row level compression. And I said the rule of thumb is if it's a heavily written tables, like we're incrementally written to, and it's not like an ETL batch process, you probably want to go with row level compressioning as opposed to a page, just because it's a less of the overhead. But if it's a batch process, you're probably very safe to go with page, which will give you the best performance improvement overall. So if I run that with the row level compression, what you'll end up with is slightly more. So you notice that basically it increased your I/O basically twice versus the page level compression. Okay. Any questions so far?
So far, the only question is, will these scripts be available for download later?
Absolutely. All right. So the other thing we were actually going to talk
about.
Go ahead.
Sorry, and as soon as we did that, a couple more questions. What version of SQL Server is the compression available in?
It's available starting with 2008.
Yep,
for sure. So 2008, 2008 R2, at least page level and row level compression is available on that. I have to double check if it's actually available in 05, but I'm pretty sure it's at least 2008 is guaranteed to be available.
Agreed.
All right, so partitioning. So you can do it in different ways. So there's, first of all, obviously in order to align the physical partition to your logical partition, your cube has to be partitioned first. And the partitioning of the cube could be actually done in a whole bunch of different ways. And it's pretty easy to do. It's not really complicated thing, and I'll show you a whole bunch of different ways. You can actually do it from your Visual Studio solution. If you do that, you actually have to redeploy the cube and reprocess it, obviously. If the cube's already deployed, and you can do it straight from the OLAP connection in SSMS. So you can do it either for a GUI or an XML query. So you can actually run a query and then add a partition to it. Now, if you do that, obviously that requires a reprocess of the cube to take effect. The thing to watch for when you're actually processing a cube, and I was kind of showing it to you in a previous demo, is even though you partition the cube, you have to have the underneath indexing to support that. If you partition the cube, but underneath on a data warehouse, it's still scanning the entire table to process your partitions, you're getting very, very minimal gains. And if you have to change your indexing to support the partition of the cubes or add additional indexes, you might actually affect other processes like ETL and so on and so forth. And the other thing to watch is obviously still, it's always going to come up as implicit conversions. Those are the killers. All right, so I'm going to show you the partitioning of the cube. So first of all, from the Visual Studio perspective, and this is the AdventureWorks cube model, and as you can see here, it is properly aligned from the physical to logical view. So this is our cube structure, and this is our DSV. So they all look very, very similar. It's actually one-to-one partition. So whatever the fact table is on the cube, it's actually a physical table on your data warehouse. So if you go to partition within the Visual Studio, you can just go to your Internet Sales or the measure group you want to partition and click the Partition tab. And then you can add a new partition through the GUI. It actually will launch almost exactly the same GUI as if you do it through SSMS. Now on the SSMS side, if you have made your connection to your cube for analysis services, this is the same AdventureWorks cube. This is our Internet Sales measure group, and if you expand the partition, it'll show you the existing partitions just like we saw. And to create a new one, you just basically create it. Right-click and say New Partition. And you can basically go through the wizard, and I'm saying basically a lot. Select your measure group that you want to add the partition to. And here what you do is you specify the query to restrict rows. Now you can actually easily cheat here. So if you know that you're partitioning by year, that's what you're adding. So this measure group is partitioned for year 2005, 6, 7, and 8. If you have any data before that or after that, it's discarded, which is probably not something that you want. You probably want to have a catch-all partitions at some point. But you can actually steal your partition definition from your previous partition. So if you double-click a partition that already exists, you can see the definition of the query that you have. So you can just copy it. If you're duplicating the same partition, click copy, cancel, And whenever you create your new partition, you can just paste that in and update the settings that you want. So I just pasted my definition of a query for 2008, and I just want to update it to 2009 year. So I'm adding a year, another year of data that I'm going to load into my data warehouse. And then you obviously, there's some other additional options you can do, saying where processing location is going to take, blah, blah, blah. Then you have to define it, what the name of the partition would be. So we'll make it the same way. Sales. Darn it. 2009. And the other thing you can do is actually design aggregations for the partition. So you can use the current, redesign it basically for the partition that you're creating. You can tell it to design it later, which will actually reduce the time to create it. If you design the aggregations for partitioning and it's a large partition, it could take a significant amount of time. Or you can use an existing aggregations that you already created for the previous partitions. So I'm actually just going to create the one I did for 2008. And the partition is created. Now from the XMLA perspective, you can just run the same query. This is what that will do. It will create exactly the same partition. So if I were to drop this partition, and execute this XMLA query, it will recreate that partition for me. Now, why did not? Where's my execute? And if you can execute that, you will see that it actually created exactly the same partition for me that I did through the wizard. Same definition, same everything. Now remember, this is just a logical model. So whenever you process your dimension, all those select statements based on the parallel threads that you actually have selected will be launched against your database as individual queries, intellectual select statements. And the more you have, if they're not properly indexed, obviously they'll take a long time, so it actually won't help you that much. All right. So now let's talk about physical alignment. So if you want to align your logical partition to your physical data warehouse partitioning, it's a little more complex than logical partitioning to implement. It also removes the needs for additional indexes to support logical partitioning if the additional indexing was required. And if you have to modify existing indexes, it removes the risk of the partitioning affecting other critical processes on the server. The other really cool thing about physical partitioning, you can actually take advantage of multiple storage locations for I/O separations. So you actually can spread the table against multiple disks, which will actually, again, also increase your I/O performance and, again, will help you process things faster. So in order to take a look at that, I actually have a demo for that. All right, so in order to actually create physical partitions, there's a little more things to do. And you can't do it from the GUI, you actually have to do it all through scripts. So first you actually, and you can do it in a multitude of ways. You can actually don't have to create a specific additional file groups, you can all do it to the primary file group. But if you want to take advantage of I/O separation, meaning having different disks, you actually want to have different file groups so you can actually move that around. Even if you're not going to be using it right away, it's still a good practice. So if the need arises in a later time, you can actually already have everything set up for you. So all you need to do is actually create. I'm going to create 5 file groups within my database. And then I'm going to create 5 files for each file group. Now, in my particular case, I'm obviously going to the same disk because I only have one disk. But if you had multiple disks, this is how you actually can specify different disks in here for the locations. And now we're ready to use the partitioning. And in order to partition, you actually have to specify, create a partition function. And you can do it 2 different ways. You can do it for range right or range left. A lot of times it's for values of, if you use in surrogate keys, it would be integers. So you have to specify what kind of function it is. So it's an integer, or it could also be dates. That's probably the 2 most common partition functions you'll see. It's either partitioned by date or an integer. And generally, I would recommend using actually a range right, especially if you have to split partition, and it makes your life easier. And if you ever wanted to do, like, take it to the next level and actually do like a sliding window partitioning setup, that plays really well with that kind of setup. So we're going to do a range right, and those are my boundaries that I'm creating for my range right partitions. So it's going to align with my logical partition in the cube. So create my function. Now I have to map the function how it's actually going to be laid out to the table. So I have to actually map how those boundaries are going to define where the data and which file group they're going to go. Now this is where you can actually say which file groups they're going to go, or you can say all go to the same file group, or you can reuse the same file group, or you have like a round robin rotation. If you only have 5 disks, you can just keep rotating them, like, you know, part 1, part 2, part 3, part 4, part 5, and then 1, 2, 3, 4, 5, and keep going. It kind of depends on your data usage patterns. Oh. Didn't I create part 1? Okay, that's really weird. Oh. It helps if I actually switch the database. All right, had me scared for a while. So now, now we're ready to actually partition the table. In order to partition the table, all you have to do is actually to specify, whenever you're building your clustered index on a table, to use the partition schema that you actually created and the column that actually will divide the table, which is the boundary column. So in my particular case, my schema is partition schema order date, so I'm specifying that right here. And the column that I'm using is actually order date key. Now, the one requirement for partitioning, the partition column has to be part of the cluster key. And it's the only way how it actually knows how to partition the data. It has to know how the data is stored on the table. It doesn't have to be a seek predicate, so it could be the last column if you have a composite cluster key. It could be absolutely the last column on your cluster key. So you can still use your cluster key to seek for the other data, and the partition column just has to be part of it. So once I create that, it will actually partition my table across those 5 disks. And this is a query that's actually available to see how your data is distributed through the partitions. It actually uses some DMVs to figure out what we have. So we have 5 partitions. We added the last one, which is the 2009, and obviously there's nothing in there because there's no data in the table. And this is the data distribution between the partitions rows and the partition numbers. So this 2005, 2008, you can actually look at the Visual Studio and you can see that the estimated rows actually kind of very closely line up here. At least that's what you want. They're not going to line up perfectly all the time, but they should be very, very close to what you actually want to do. And if I actually run my query now, what you'll notice is actually that my I/O, and I'm going to increase the font here really quick, my I/O actually dropped even a little more from just having index seek. So because I'm using partition elimination, it actually knows exactly where the partition starts and partition ends. With an index seek, it's still an approximation. It's kind of based on your statistics. So it's kind of knows kind of the starting point, but not guaranteed. So it's going to get close, and it might actually read a little more than it has to get you the data that you want. With partition elimination, it's almost an exact process because it actually defined by the boundaries of the partitions. And again, on a very larger sets, that actually can play a pretty big role in your improvements as far as that is concerned.
Hey, Konstantin.
Yes.
We've got several more questions. Just want to let you know whenever you're ready for them. No rush.
Okay, I think we're almost done. I said I just wanted to show one thing for incremental processing. There's something that's called the process add functionality. Now, the only way that could be done is actually through XMLA queries. You can't specify that when you're processing a cube. So it's basically like a piecemeal process of your cube, and you're only adding what's actually changed or being inserted into the fact tables or dimension tables. You must really know your data to see if it worked for your environment. If there's a lot of updates going on, that might not be the best thing. But if you're just adding data to your fact tables from ETL processes, that might be something that you want to consider. And it's still recommended to do a full process within a certain period to actually get a clean build of your cubes. And so the only thing I have is I want to show you what it looks like. So this is, again, it's an existing customer, and this is their process add functionality. And the only thing that you're looking for is the type of the process is the process add. And it actually will add, this is a dimension that's actually being processed. And that's kind of it. So the questions, just wanted to also kind of sum that all up. Make sure you configure your topology to best suit your business needs. That's kind of like the key thing. If you can use the best practices features, by all means do them. That will actually help you a lot. Sometimes you're kind of limited by the environment that you're in. Definitely use your compression features. That's almost a no-brainer within the data warehouse. It's kind of almost a must. And physical and to logical model alignment will also help you greatly as far as your performance is concerned. All right, questions?
All right. So there's quite a few of them, so I'm going to read them really fast and just let me if you need me to repeat them. I'll start out with the easiest one. What to do if the fact table does not have a clustered index?
I would definitely recommend creating one. Again, kind of go through for what your queries look like. If your cube is partitioned on some certain keys, that probably would be a great recommendation for your cluster key. Whenever not having a cluster key will help with loading the data in. That would be really fast because it's unsorted. However, when you're reading, even if you're reading the entire table, the CPU overhead of the heap is significantly more than the CPU overhead of a clustered index scan. So you'd probably always look into having a clustered index on your fact tables.
All right. Are there any performance improvement that can be done for standard edition as compression is only available in enterprise?
Well, not from the compression perspective, obviously, but you said that's when you actually start looking for like the best practices, like where you doing your calculation. Are you doing like a lot of calculations part of your queue process? Are you doing any kind of implicit conversions? I mean, do you have proper indexing in place? Because you also, if you're using a standard, you also limit it in your memory. And then that's where it's really going to play in how much actually you're using to load into your buffer pool to actually retrieve your data. So if you can streamline it as much as possible, that will help you greatly as far as your processing needs are concerned.
All right. Do you recommend creating indexes on your fact table, clustered index being the emphasis? What would be implications if your table has hundreds of millions of rows?
You lose a little bit on space as far as just the clustered index takes a little more space on disk than if you didn't have one. If you're doing destructive loads, that could be a problematic thing as well because again it is a sorted index. So if you're not doing destructive load, it shouldn't be that big of a deal. And also if you're also using physical partitioning of your tables, actually will also help greatly. But if you are doing destructive loads, what usually happens a lot of times, people actually drop your cluster, like all the indexes on the table, to speed up the load as fast as possible. They just pump data as fast as they can, and then they create indexes afterwards.
Interesting question here. Does the partitioning work the same way for SSAS tabular models?
That is an interesting question. It should. I'd have to double check. I mean, as far as the physical alignment, it should be. And it's basically based on the queries that actually the cube is pulling, or the OLAP is pulling. So if it can use partition elimination from the physical model, it will still do it. I haven't actually set that up to double check, but I will probably do that now.
All right, and here's a great question. Can you just have a single non-primary file group with multiple files spread across several volumes? I guess what I'm asking is why you need multiple file groups as opposed to just many files.
Well, because that's having multiple files. So the table, whenever you create a table, it'll pick a file and create that within that table. It will not span the table, the files across, the table across multiple files unless they're in a separate file group. It'll keep the same file within the file group. You can do that. You can still, but then that actually creating multiple file groups give you a greater measure of control how your data is separated between the different disks that you have. But I've seen implementations where it's a one file group and they have multiple files and they're all coming from different LUNs. Just so having multiple file groups give you better control of how your data is actually separated across the disks.
All right, here's a good one. Is compression affecting index fragmentation, particularly about performance?
No, it does not. I mean, it's the same. Like if your index are going to get fragmented, it's going to be fragmented regardless if it's compressed or non-compressed.
And there was a question earlier about can you disable compression, do your load, and then turn compression back on?
You can, but a lot of times actually that will be slower just because it's compressing as it's writing to disk, and again, if it's writing less data, it might actually go faster just because the disk is the slowest part again. And in order to disable compression, all you have to do is actually say data underscore compression equals none, and that will take the compression off.
Here, this next question is probably a great one for highlighting the nuances here. Can we apply different compression techniques for different file groups?
Compression techniques are based on object. So you actually can compress a table with page and the indexes that are defined on a table with row and actually leave some of the things uncompressed. So yes.
Great answer. In your example, you only did one index compression. What about if we have several indexes in the table? Do we have to compress all the indexes on that table in order to gain the speed?
Only if they're being used. So like the only reason I compressed the clustered key, I actually compressed the table itself. Whenever you compress the clustered key or the heap itself, which is the alter table statement, you actually compress the actual table. The non-clustered indexes are stored separately from the table, and you can compress them, but if they're not being used to pull your data out, that's not really necessary because they're not going to be used. It will give you the space saving on your disk subsystem because it'll take less space, and you do it exactly the same way. It's bind objects. It's an alter index rebuild with data compression and the setting for the compression that you want.
All right. Next question is there a recommendation for number of file groups? Is it based on number of physical channels and physical devices attached to those channels?
It's actually a loaded question. That varies. The answer here is actually it depends. It depends what your disk subsystem is. I mean, if you're using a SAN, I mean, are you coming from the same RAID groups? Like a lot of times now, SANs are tiered storage, so it's one big happy family. So it kind of depends what your disk subsystem is. Sometimes you could be using 2 different SANs. Sometimes you could be using, if it's a VMware implementation, some disks might be using like SSD volumes. So it depends what you're processing. So the number of file groups is kind of like what your disk subsystem can take. That's what your bandwidth is to your channels. So in a way, it is how many channels you have, how many paths you have to your disk, and what the throughput would be.
All right, and then how can you programmatically create cube partitions instead of doing it manually?
Through XMLA. You can actually have jobs. I mean, that query that I showed for the creating a partition of XMLA, you can actually do that programmatically. You can have a job that actually updates that query to set for the new year, and it just on a monthly basis, and it just runs and create a new partition.
Wow, we're burning through these questions pretty quickly. We've got time for a couple more if people have them out there. Searching for the next one. Oh, here's one. Back to the basics of it. Asking if the compression is limited to databases that are staging for cubes, or can you do it with regular normal relational databases as well?
You can do it on any database. Just said be careful with regular relational databases because that's when you actually can hurt yourself. If they are really heavily written activities, make sure you use row level compression as opposed to a page, because then you can actually spike your CPU utilization and actually will be more of a detriment than a help.
All right, we've probably got time for maybe 2 more questions if anyone's got some that we haven't gotten to yet. Looks like we've got one for a bridge dimension. Is it recommended a row compression over page compression?
For dimensions?
Bridge dimension, it says.
It's a good question. It kind of, again, the compression setting is more how it's actually used. So if it's heavily written, you know what? Let me double check that. Let me build that, and then I'll post something on rdx.com for in a blog to actually answer that question. Which one will actually perform better with a bridge dimension?
Does compression require enterprise?
Yes.
How much does enterprise cost? And the answer to that is ask Microsoft.
Well, the short answer is a lot.
Exactly.
It's unfortunately a lot more than standard. There's a bridge gap kind of edition, which is the BI edition, which actually lets you use enterprise level features on the Cube OLAP services. But you can't use the compression settings and physical partition alignment because that's a database engine features. But you can at least partition your cubes and actually make sure that the indexes are in place to actually support that.
All right. What about the slides and scripts? I believe they'll be available on 24hoursofpass.com next week.
Yep.
Several great session, awesome, thanks, answered my questions, a whole bunch of those.
Oh, that's great. I'm glad it was helpful for everyone.
And let's see, we might have time for maybe 2 more. I missed the first few minutes. Can you show big info again?
Absolutely. Are we talking about this?
I don't know. I may have missed it myself.
I'm not sure what the big info is. Is that
Yeah, I don't know myself. Quick question, what's your blog? Where's that at?
I mean, like, actually, we blog for rdx.com right now, so I don't have...
Okay, rdx.com. And I think we'll probably make this one the last one. What about column store indexes versus compression?
Well, the column store is already compressed, so it's already in memory compressed index, so it's actually already a compressed index. Generally, with column store, it won't help you nearly as much if you're processing your cube, because it's still selecting the data. It's not doing the aggregation within the database itself. It's doing the aggregation within the cube. It might help you more with a tabular model, and if you're doing like a reporting data warehouse where you actually don't have a cube, you're actually doing aggregations off the fact tables for your reports, then it's definitely a perfect scenario for your column store indexes.
All right, if you want to go ahead and throw up that second to last slide.
Absolutely.
I'll get us moving out of here. Perfect. All right. Thank you for attending Optimizing Your Data Warehouse for OLAP Processing. I'd like to thank Konstantin for his time and expertise. Again, I'd like to also thank our presenting sponsors, Microsoft, Cisco, and Dell Software, and our supporting sponsors, SQL Sentry, HP, and SolarWinds. We hope you enjoyed the session as much as we did. Follow along on social media with the Pass24HOP Twitter account, and share your thoughts on the event with hashtags Pass24HOP and SQL Pass. Stay tuned for our next session, Turbocharge Transaction Logs with David Maxwell, happening in a few minutes. And thanks again, Konstantin.
Well, thank you, everyone.